Hello everyone, welcome to the class. In today's class, we will be starting a new chapter, that is the study of gas laws. Okay, it is chapter 7 of your book. So in this chapter, we will be discussing about the properties of gases. Okay, what are the characteristic properties of gases? What are the law? What are gas laws? There are two laws. Okay, first is you have to do Boyle's law, and next you have to do Charles' law. Okay, so a statement of Boyle's law and Charles' law you have to study, and its importance of Boyle's law and Charles' law we have to do. And there is a combined form of gas laws. Okay, Boyle's law and Charles' law, it is combined and give a single statement is given. Okay, that also we have to discuss. And then ultimately we have to do some numericals based on this Boyle's law, Charles' law, and combined form of gas laws. Okay, so let's proceed step by step. First of all, you write one question: state some characteristic properties of gases. State some characteristic properties of gases. And in answer, write down some characteristic properties of gases are: number one. Okay, number one, gases are composed of tiny particles called molecules. And add here which are in random, RANDOM, random ceaseless, CASELESS, ceaseless motion. First property is this. Okay, gases are composed of tiny particles called molecules. Gases are composed of molecules which are in random. Random means in any direction. Suppose this is a container and here you have some gas molecules. These molecules can move in any direction. Okay, in any possible direction. So random is that. Ceaseless means never stopping. This word means CEASELESS. Ceaseless means never stopping motion. Okay, ceaseless motion means never stopping motion. Okay, next property number two is gases exert pressure in all the directions. So gas exerts pressure in all possible directions. So if you have kept a container, gas in a container, okay, so this gas molecule exert pressure on this wall. It might exert pressure on this wall also. It might exert pressure this side also, and but exert pressure in this side also, or in this direction also. Okay, so gas exerts pressure in all possible direction. Pressure means force exerted per unit area. Definition of pressure I'll give you later. Okay, next, gas are highly, HIGHLY, gases are highly, HIGHLY, highly compressible. This word means, see, suppose if you have a gas in this big container, okay, oxygen gas you have here, so this gas can be compressed and it can be kept in a smaller container. All these gases can be kept here. It can be compressed, its volume can be decreased. Okay, that is compressible. Gases are highly compressible. Suppose if you have say 50 liters of 50 liters of gas, you can compress it and make its volume little lesser. Okay, that is the third statement. Next is gases are highly expansible. Gases are highly expansible. You can expand the gas by heating. Okay, suppose you have gas in a small container. This oxygen gas is here. This can be heated and the gas molecules can be this gas can be, its volume can be expanded and it can be kept in a bigger container. It can be kept in this bigger container. Okay, volume can be expanded. Next, gases have low density. Density of gas is very low. Okay, next, gas have a natural tendency to mix with one another. Suppose if you keep oxygen gas and hydrogen gas together in a container, then they get diffused. The molecules will mix with each other. Okay, so that is called that is the tendency to mix with one another. Gases has tendency to mix with one another. That tendency to mix with one another is called diffusion. Remember this word, diffusion. You might have done in biology also. Osmosis and diffusion, that is there in biology. Next, gases can be liquefied by cooling it and applying pressure on it. You can liquefy gases like the gas that you use at home, LPG, liquefied petroleum gas. Actually, it is a gas, but it is liquefied in the cylinder. Okay. So gases can be liquefied, and liquefaction of gas is done by cooling the gas and by applying pressure on it. And the last statement is gases have neither a fixed volume nor a fixed shape. So if you have a small amount of gas, that gas you can put in this container. That gas will fill whole this container. Okay. And same gas if you put in a bigger container, again that gas will occupy the whole volume of this container. Okay. So gases neither has a fixed shape nor has a fixed volume. If you keep in a glass, if you keep pour gas in a glass, okay, then it changes to the shape of glass. If you place that gas in a bottle, then it turns into the shape of bottle. So gas doesn't have a fixed shape. And similar manner, liquid also has no fixed shape. Now next question you writing, state the relationship between okay, BETWWN, I have written in short form, between kinetic energy, KINETIC, kinetic energy, and the temperature, temperature of gas molecules. Temperature of gas molecules. Okay, answer is the kinetic energy of gas molecules is directly proportional to its temperature. Okay, directly, DIRECTLY, directly proportional, PROPORTION, proportional. Mathematically, you write it KE stands for kinetic energy. Okay, this is the symbol of proportion, proportional to temperature, T. KE is directly proportional to the temperature. Now, meaning of this word directly proportional, it means if temperature increases, kinetic energy also increases, and if temperature decreases, kinetic energy also decreases. That is the meaning of directly proportional. If one quantity, if one parameter, okay, if it increases, other also increases, and if one decreases, another also decreases. That is direct relation. Okay, directly proportional. So statement you write it, the kinetic energy of gas molecules is directly proportional to the temperature. Okay, and mathematically you write this one, mathematically MATHEMATICALL, mathematically KE proportional to T. This is symbol of proportion. Okay, PROPORTION, symbol of proportion. Next question you write on, why KE of gas molecules increases with the increase in its temperature. With the increase in its temperature. Why? Kinetic energy of gas molecules increases with the GAS. Okay, gas molecules increases with the increase in its temperature. So answer you write it. With the increase of temperature, the random motion of gas molecules increases, and due to this, the kinetic energy also increases. Okay, so what happens is, these are gas molecules. Right now it is at say 25 degrees Celsius. At present it is at 25 degrees Celsius. At 25 degrees Celsius, the molecular velocity of these gas molecules, say let it be 50 meter per second. The speed of gas molecules is 50 meter per second at 25 degrees Celsius. Now if I increase the temperature of this gas molecules, okay, this gas, if I change it to 50 degrees Celsius, then the random motion of this gas molecules also increases. That means the velocity of this gas molecules increases, and let the new velocity be 90 meter per second. 90 meter per second, let it be 90 meter per second. Then now kinetic energy, see, it increases. So previous original ke was half mv square. This is the formula of kinetic energy. Half into mass, for this molecules mass is constant, okay, mass into velocity is 50 square, so it will be half m into 50 square, 2500. So you can cancel this and you can write 1250, 1250. And if 1250 m, okay, this m means mass of gas molecules. Now in new case, velocity ke, new case ke will be equals to half mv square. Half mass is same, velocity it is changed to 90 square. Half m into 90, 9 9 is 81, 00. Okay, so you can cancel 2 4 is 8, 2 0 is 0, 2 5 is 10. So 4050 m. So new kinetic energy is 4050 m. M is mass of gas molecules. Okay, original was 1250 m. So with the increase of temperature, the molecular velocity of gas increases, and due to this kinetic energy also increases. So that is the statement. No need to give this example, okay, just write the statement only. So statement, what I said is, with the increase of temperature, the molecular velocity of gases increases, and as a result of this, the kinetic energy also increases. Okay, now let's move to another topic. Okay, name the 3 standard variables which are required to describe the physical behavior of gases. So answer will be, the 3 standard variables which are required to describe the physical behavior of gases are temperature. Number 1 is temperature. Okay, temperature. Number 2 is pressure, and number 3 is volume. VOLUME, volume. So in order to study about gases, and its behavior, you should first know 3 things. Okay, what is temperature, what is pressure, what is volume. And with this respect, on the respect of temperature, pressure and volume, we will study about the physical properties of gases. Okay, so these 3 this behaviors, 3 variables. Okay, these 3 variables are very, very important: temperature, pressure and volume. With respect to these variables, we will study about the gases, and Boyle's law and Charles' law is also dependent on these 3 variables only. Okay, so this much for today's class. I will continue the remaining portion in the next class. Okay, in next class I will be teaching you about Boyle's law. First of all, I will teach you about Boyle's law. Next I'll teach you Charles' law, and number 3 I'll teach you combined form of Boyle's law and Charles' law. Before that, we have to do the definition of temperature, its units. Okay, next definition of pressure, its unit, and definition of volume and its unit also we have to discuss. Okay, so that I'll do in another class. Thank you.